Hi everyone. Today we're going to start our review of using integrals as net change and some applications of integrals in general. So most of today, like I said, is going to be review topics, right? So we're going to start off with a concept that we've studied quite a bit, acceleration, velocity, displacement questions. So in all of these problems, right, v of t is going to be 6 sine of 3t. We're going from 0 to pi over 2 inclusive, right? That's our velocity function. We have units here, meters per second, for some particle moving along the x-axis. So group problem 1 says, determine when the particle is moving to the right. So this is reviewing stuff from Calc A. We know that that means we want where velocity is positive. Moving to the left, that is where velocity is negative, and standing still is where the velocity is equal to 0. So let's take our velocity equation and let's set it equal to 0. Now we should also check to see where it equals does not exist, but since this is a sine curve, we know it's going to always exist, right? So we can skip that for now. 6 sine of 3t, set it equal to 0. First step, divide everything by 6. Still, you get sine of 3t equal to 0. And now let's think back to what we did in trig, right? We're trying to set sine basically equal to 0, right? So what are the values of 3t, right? So that when we take the sine of it, we get 0. And so we get a bunch of values, right? Like 0 and pi and 2 pi and 3 pi and negative pi, etc., etc. I would write out a few more of these just to be safe, right, than just the ones in the unit circle. Because remember, we need to solve for t values, not 3t values. So I would write out a few more because now to get t by itself, I divide everything by 3. And now I get a whole bunch of angles that look like they should fit in the unit circle, right? And nice thing for us though is that, we're only going 0 to pi over 2. So we actually only get a couple of answers here. We get 0 and pi over 3. Now, lucky for us, right, 0 is an endpoint, so we already knew to consider that. So I'm going to do first derivative test here. I'm going to make my little number line, right, and I'm going to start checking intervals. So my values, 0 and pi over 3, right, and we're only going up to pi over 2 here, but in general, right, I know that the next time my function is going to change signs could theoretically be at 2 pi over 3, okay? So I'm going to pick some values here. So first off, I'll pick pi over 4, right? Sine of 3 pi over 4, that's going to be positive, okay? And then something bigger than pi over 3, but less than 2 pi over 3, I will pick pi over 2, right? Sine of 3 pi over 2 is going to give me a negative. Now again, typically I wouldn't like to pick something that's an endpoint for the interval, but again, I'm focusing on where sine is going to change SIGN signs. So as long as I pick something between pi over 3 and 2 pi over 3, I know I'm okay. Okay, so I can use this. Let's check some answers then, right? Moving to the right is wherever velocity is positive, so that's going to be from 0 to pi over 3. Moving to the left, velocity is negative, pi over 3 to pi over 2. Standing still is where the velocity is 0, and for this I have specific t values, right? And so I will add units here, 0 and pi over 3 seconds, okay? Okay, so that's all Calc A right there, right? Calc A trig review. Let's bring it back to some stuff we've done this year. So group problem 2 says to compute this integral. So integral from 0 to pi over 2 of v of t dt, and explain what this expression represents in terms of the particle. So we'll get to the explaining part at the end here. Let's just go ahead and do a little bit of review here, right? So 0 to pi over 2, right? 6, I can, put the 6 on the outside if I want. Sine of 3t, I'm basically just going to do reverse chain rule. I'm going to divide my antiderivative by 3. Antiderivative of sine is going to be negative cosine, right? 6 divided by 3, I get 2, and so I get negative 2 cosine of 3t. Remember that we have to plug our bounds into this because we're doing fundamental theorem here, pi over 2 and 0. So let's go ahead and plug those in. So we get negative 2 cosine 3 pi over 2 minus negative 2 cosine of 0. So double negatives there turns that into a plus. And one of the places I see some very silly mistakes is, of course, with the unit circle. Cosine of 3 pi over 2 is 0. Cosine of 0 is 1, right? And so I get a final answer of 2 here, okay? But specifically 2 meters, right? Because what does this integral represent, right? If I'm just taking the integral of the velocity function, that represents the displacement. And remember, for displacement, we can call it delta x, delta s, right? Whatever your position function is called, right? It is the change in position, right? So if you were asked to explain what this integral represents on an FRQ, right, we could say something like the displacement of the particle in meters from 0 to pi over 2 seconds. Don't forget to talk about the units of your bounds along with the units of the integral itself. Okay. Okay, so let's keep going, right? Group problem 3. Compute looks like the very same integral, except one big distinction. We are taking the integral of the absolute value of v of t dt, right? Now, one of the most common mistakes I see students make, I should say, is they will take their work from group problem 2 and just take the absolute value of the answer. That is incorrect. What we are taking the integral of is the absolute value of the function, right? And so we're going to get theoretically a totally different graph, right, of compared to v of t, right? And we want the area under the curve of something that could look totally different. So the good news for us is we've already done part of the work, right? And the hint here says split into 2 integrals to compute numerically, right? What's going to help us with that is our work from group problem 1, which is setting the v of t function equal to 0 and checking to see where it's positive and negative, right? Because the way we split this up, remember, what does an absolute value actually mean? It means any input that is positive stays positive. From 0 to pi over 3, v of t is already positive. So I don't need absolute value here, right? It doesn't do anything for any inputs from 0 to pi over 3. And so that part is going to remain the same. But from pi over 3 and up till 2 pi over 3, right, we know that v of t is negative. And so what absolute value of v of t does there, right, is it takes your negative input and it multiplies it by a negative 1. And so I'm going to subtract the integral from pi over 3 to pi over 2 of v of t dt. Okay, and now the good news for us is calculating this, once we've already done group problem 2, right, doing all this work is very similar. We already know what the antiderivative is, right? Go ahead and write, negative 2 cosine of 3t, right? With the second integral, again, I get a double negative situation here, right? And so that's going to turn into plus 2 cosine of 3t again. Now be careful here. It's very easy to kind of start mixing and matching stuff, right? Do these separately, okay, right? Do these separately. We have to plug 0 and pi over 3 into this one, fundamental theorem, right? Pi over 3, pi over 2 into this one, subtract them, right? Because again, because of the fundamental theorem, okay? But let's go ahead and plug these things in and help ourselves out. So pi over 3 goes in. This becomes cosine of pi, which is negative 1, times negative 2, which is positive 2. Plug in 0, right? Cosine of 0 is 1, but it'll be minus negative 2, and so that becomes a plus, okay? And then for the second part, right, you've already plugged in pi over 3, right? And so we already know that part is going to give us 2, or in this case, it'll be negative 2, right? Because we're going to be subtracting that, okay? And then plug in pi over 2, we get 3 pi over 2, that's going to be 0, okay? And so, yeah, we can go ahead and plug that in, right? And add everything together, and we get 6 meters, right? So what does this integral represent, right? If I am taking wherever the velocity was negative and I'm taking its absolute value, right? I know that I'm going to get positive from that. And so even though the particle was moving backwards on the interval from pi over 3 to pi over 2, I'm still ending up adding its distance on to wherever the particle was moving forward, right? And so this gives us total distance traveled. Okay, and again, if this was a real FRQ, right, you would say over the interval 0 to pi over 2 seconds, right? You would talk about that as well. But the thing that we want to focus on today is just kind of reviewing what some of these basic integrals mean in the acceleration velocity types of questions. Okay. Okay, group problem 4. Given that s of 0 is 3, compute the final position of the particle. Now remember, our interval was till pi over 2, right? And so what we are looking to find is s of pi over 2. Okay, so this is going to be an integral as a net change question here. Okay, we are trying to find s of pi over 2. That is the final position, right? I am going to start at the value that is given, which is s of 0 equals 3, right? That is going to be my initial position, right? And what am I going to add on to this? I'm going to add on, let's go back, right? That would be the displacement, right? The displacement integral of velocity gives me the change in position, right? Whether it's positive or negative, right? And so from s of 0, if I add on the integral of v of t dt from 0 to pi over 2, right? Again, in this specific context, we call it displacement, but in general, right, it is the net change in whatever your v of t is measuring the rate of change of, right? Velocity measures the rate of change of position, so when I take its integral, I get net change in position. And so, what are these values? We are given s of 0 is 3. We already computed in group problem 2 that the displacement was 2. Add them up, we get 5 meters for our final answer. Okay, so last thing then, just to kind of summarize, right? We did 4 problems here, right? But the first one, that was all Calc A review. But in general, right, 4 things that we should try to remember. Okay, first off, displacement, right, is the integral of velocity over some interval a to b. Okay, total distance traveled, right, is the integral of the absolute value of velocity over the interval a to b. And the thing that students forget or struggle with on a no-calc question is they go, how do I split this up, right? And so you have to do stuff that you would do back in Calc A, right, which is figure out where your velocity function is positive or negative. Anywhere it's positive, you just leave it exactly as it is. Anywhere it's negative, the velocity is negative on this interval, you just subtract that integral, right? Because you would get a negative number, right, from that integral. Double negatives, that's going to turn it positive. Okay, so that's the part on a no-calc one that students struggle with. If it's calc, you could just, of course, type the whole thing straight into your calc. Okay, initial position, right, would be s of a, or, depending on what your position function is called. I just kind of assumed it's s, right? We're told it's s of t right here. Okay, and then the last thing then is final position, right? So this would be s of b equals s of a plus your displacement on that interval a to b. Okay, so that's really it for today. Just kind of reviewing some stuff we did a few chapters ago. Last thing I'd want you to take a look at is group problem 5. Okay, so this might be a good time to kind of pause the video here and try group problem 5 yourself. The last part of the video here is just going to be me showing you my work and my answers for these questions. Okay, so I will do that and then I will see you next time.